So problem 50 says, remember Gauss, the mathematician from lesson 10.1.3, that's the part we skipped yesterday. His teacher tried to keep him busy by asking him to add the numbers from 1 to 100. Legend has it that Gauss did not show any of his work, but he is commonly said to have used a method that starts with these steps below. So examine his work and what is he doing? So I'm going to copy that on my paper. You may want to do the same. Sorry. Okay, so this is what I wanted to share. So I just copied it down. So again, his teacher asked him to add the numbers 1 through 100. So what he actually did here was he added 1 through 100. He added it, he put it together twice. He added this series to itself, but reversed the order, I guess is how I'd want to say that. So again, he added it to himself, but he reversed the order. So he went 1 plus 2 plus 3 all the way to 100, and then he started with 100 and counted backwards until he got to 1. So when he added these together, how many 101s is he adding together? That's a question. You can type it in the chat. So 2S has how many 101s added together? So down here, 101, 101, 101 plus dot, 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 101, 101, 101. How many of those 101s is he adding in this bottom row? All right, there's a few people in the chat. What do you guys think? I can wait. We don't have a lot to do today, so we have time to wait. Let me know what you think. How many 101s is he adding here? And if you're not sure, you can say that so I know that you're not just ignoring me. So he actually has 101s added together. Because so this right here, 1 plus 2 plus 3 all the way to 100, there's 100 terms there. This 100 plus 99 plus 98 all the way to 1, there's also 100 terms there. So he's just adding straight down. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. And same thing over here. That'll happen everywhere in the middle also. Like 45 plus 56, that'll also give us 101. So since there's 100 terms, he has 100 101s added together. So that tells us that 2s is equal to 5,050. Or just kidding. Ignore that. Don't write that. That's what I was jumping ahead. So 2s is equal to 10,100. Because 100 times 101 is 10,100. So that tells us that the sum is really 5,050. So if you add the numbers 1 through 100 together, you're going to get 5,050. I'm going to skip part C. Part D wants us to use the same idea. So he's adding 2 plus 5 plus 8 plus 11 plus ... all the way to 59. So again, it wants us to use this idea, not our shortcut that we already know. So if I do it, we can tell that it's growing by 3 here. So if I reverse the order, it's going to be 59 plus 56. It's going to go down by 3 plus 53 plus 50 plus ... all the way to 2. That tells us that 2s is 61. So again, I'm just adding straight down. Plus 61, plus 61, plus 61, plus 61. So they're all going to be 61 here. So we have to figure out how many 61s we're adding together. So this one's a little bit trickier. So we know 2s is equal to 61 times something, but we don't know what that something is. We don't know how many of these there are. So we need to figure out what term 59 is. 2 is the first term, 5 is the second term, 8 is the third term. So for 59, or for this series here, we want to figure out what the sequence generator is. We know it's T of n equals 3n. It's growing by 3. And then whatever the 0th term is. Remember, this is the first term. So if I work backwards, the 0th term would have been -1. Again, that would be the 0th term, or the starting point. And 3 is our growth, or the common difference. So if I want to figure out what term 59 is, I plug it in for T of n. N equals 20. So that tells us 59 is the 20th term. Which means we have 20 61s here added together. So that tells us that 2s is equal to 1,220, or s is equal to 610. So 2 plus 5 plus 8 plus 11 plus all the way to 59 growing the same way is going to be 610. All right, questions on that one? Okay, so I'm going to show you 51 and then we'll take some notes before we answer kind of the questions on it. Okay. So we could have rewritten part D. So that part we just did 2 plus 5 plus 8 all the way to 59 using summation notation. So if you click on it, it gives you the definition here, which is what this goes through. So this is summation notation. The symbol sigma, this little weird looking kind of capital E thing, that's a Greek letter called sigma. It indicates that the terms generated as C changes from 1 to 20 are summed. So C down here, they use C. We can use any letter we want. We're starting at 1 and we're counting to 20. So terms 1 through 20. And sigma means you're finding the sum. You're adding those together. This part right here, it's in the bracket. Sometimes we put brackets. I don't usually. Doesn't matter. That's called the argument. So it's the rule for the term of the series. As you can see the table at right, when C equals 1, then T of 1 is 2 plus 3 times 1 minus 1. So if we plug in 1 here, 1 minus 1 in this parentheses goes away, or it becomes 0, I should say. So 3 times 0 is 0, plus 2 is 2. So the first term is 1. Sorry, the first term is 2. The second term is 5. The third term is 8. All the way down, and the 20th term is 59. The letter C, that's called the index, which represents the term number as a series terms are determined. It could also be written, this is how we wrote it on the right, as -1 plus 3p. Well, we put 3p minus 1, but it's the same thing. They just distributed and started with the first term here. But it could also be written starting at 0 and going to 19. This is not as common. Most of the ones we're going to do will start at 1, but it can be rewritten either way, just kind of a heads up there. So let's go ahead, and I think I want to take notes on this before we try this problem. So we're going to title these summation notation, and then we'll come back and answer those couple parts. Oops, sorry. I'm not sure what's going on with my camera right now. Okay. Sorry, I don't know what was going on. So summation notation. All right. So this symbol is sigma, which means find the sum. This right here, so p equals 1. This means start at 1, by plugging it in for p, and plug in numbers all the way to 20. Because that guy right there is 20. So you start at 1, you plug in 1, you plug in 2, you plug in 3, you plug in 4, 5. So you're just counting, going up by 1 all the way to 20 here. And this guy in the middle, or in the parentheses, is the argument, which is the rule for the terms of the series. This p equals 1, this is also called the index, just so you know. I'm not too big on knowing that this is called the index. You need to know that this notation means it's a sum. You should know it's called sigma, and this is the argument, but this is what it means you do. That's the more important part here. So this problem, what this means, so for sigma, I'm going to rewrite the first thing, the whole thing again. What this means is we do -1 plus 3 times 1 plus -1 plus 3 times 2 plus -1 plus 3 times 3. So I just take this whole thing, I plug in 1, then I plug in 2, then I plug in 3, then I'm going to plug in 4, and I keep going. I'm going to end up plugging in 19, and then my last term I plug in will be 20. So that's what this means. You take 1 and plug it in, then you plug in 2, then you plug in 3, then 4, and so on. So this is -1 plus 3 is 2 plus 5. If I just simplify each of these sets of parentheses, this one is 8. This one is 11. This one is 56. And this one is 59. So again, 3 times 20, 60 minus 1, 59. 3 times 19, 57 minus 1 is 56. So that's what this means. But this is an arithmetic series. So if we're actually finding the sum here, 2 plus 5 plus 8 plus 11 plus all the way to 59. So it's an arithmetic series, so we can use our formula. The sum is equal to 20 divided by 2 times 2 plus 59. This 20, because there are 20 terms, This 2 is the first term, and the 59 is the last term. We get 10 times 61 is 610. Which we got the same thing on the last problem, doing it a different way. No, we're not going to have to write this out every time. I just want you guys to know what this notation means. Also, this is kind of what the book said. This same series could be written as sigma from p equals 0 to 19 of 2 plus 3p. So this and this are the exact same thing, because here we start by plugging in 0. So 2 plus 3 times 0 plus 2 plus 3 times 1 plus 2 plus 3 times 2 all the way to 2 plus 3 times 18, and the last one will be 2 plus 3 times 19. So again, I'm plugging in 0, then 1, then 2, all the way to 18, and 19 is the last one. So this is equal to 2 plus 5 plus 8 plus 56 plus 59. So when you're setting it up, you can do it either way. Again, we're most commonly going to have it as p equals 1 as our index that we're starting with. This guy still right here, this still has 20 terms, even though it only has 19 at the top, because we're starting with the 0th term here. Here you actually count when you plug in 0. So this one's a little bit different. All right, and then we'll just do a couple of examples. This one is arithmetic, but they're not always going to be. So example, write out the series and calculate the sum. So we're going to do the sum when j equals 0 to 5 of j cubed minus 1. So again, this means basically we're going to just plug in 0, cube it, subtract 1. 1 cubed minus 1, 2 cubed minus 1, 3 cubed minus 1, 4 cubed minus 1, and 5 cubed minus 1. So again, the same thing, but I plug in 0, 1, 2, 3, 4, and I stop at 5. And then, so I just do each set of parentheses. 0 cubed minus 1 is negative 1. 1 cubed minus 1 is 0. 2 cubed is 8, minus 1 is 7. 3 cubed is 27, minus 1 is 26. 4 cubed is 64, minus 1 is 63. Plus 5 cubed is 125, minus 1 is going to be 124. We want to be careful here. This is not arithmetic. So you have to add all terms without a shortcut. So up here, we use the shortcut because it was arithmetic. This isn't arithmetic. This isn't in the form like y equals mx plus b. It doesn't have that common growth. So we actually just have to add them. Not terrible. -1 plus 0 plus 7, 26, 63, and 124 gives us 219. And we'll do one more example. Kind of a little bit harder. We're going to say write in summation notation. Nine plus 14 plus 19 plus 24 plus 29 plus 34 plus 39 plus 44. So you're given the series on this problem and we want to write it in summation notation. All right, so let's see. I'm going to start it at 1. I personally think it's a little bit easier. And then, so 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms here. So our index, I chose K, starts at 1 and it goes to 8. And then we need to figure out what the argument is. What's it growing by? Kind of what's the rule here? So we can see it goes from 5, it's arithmetic, 5, 14, 19. So it's growing by 5. So 5K. And then we don't want to do plus 9 because remember, if we plug in 1, we want to get 9. So we have to kind of figure out what the 0th term is. So if we worked backwards, our 0th term would be 4. If that helps you. So again, if we worked backwards, we would be subtracting 5 and we would get 4 there. But if we plug in 1, we get 9. If I plug in 8, 5 times 8 is 40 plus 4, I get 44, that last term. So when you have to write it in summation notation, you figure out kind of what you're starting with, how many there are, and then what is the rule? How do you get all of the terms in that series? Okay, so we're going to go to 51. There's parts A and B. A wants you to write this in summation notation. So 15 plus 19 plus 23 plus 27 plus 31. That's from the book. So it says use summation notation to represent this series. So try that one. And B wants you to write out the series and calculate this sum. So if you're stuck on A, try B. I'm going to give you guys, I don't know, maybe a minute or two to actually try them to see if where you're getting stuck and kind of what parts you're able to get to. So A, again, you can use any letter here. I, K, J, C, I think those were all used. So if I do I equals 1, it's going to go to 5. We can tell this is arithmetic. It's growing by 4. So your argument here would be 4K plus 11. 11 being the 0th term. That should be an I, or this should be a K. These have to be the same letter. Sorry. Doesn't matter what letter you use. You just want to use the same letter. And then B, so 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared all the way to the last one is 6 squared. That's equal to 1 plus 4 plus 9, 16, 25, and 36. Again, you can't use a shortcut here because this is not arithmetic. It's not growing linearly. So if you add up all of these terms, you will get 91. All right, and then 10-53, it tells you each of these are arithmetic and to find the sum. So they want the sum from t equals 1 to 10 of 13t minus 5. So again, this means plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then add them all up. Here in part B, the book said write out the series. Here they just say find the sum. We do not have to write out all of the terms. So because this is arithmetic, we could plug them all in if we wanted to, but that's going to be more work. You're going to have to get all 10 terms and then add them up. Or we can just use our shortcut. For arithmetic series, we know that the sum is equal to n divided by 2, and then the first term plus the last term. So that's what we wrote in our notes yesterday. So we're able to use that here. So here we know that n is equal to 10. We're going from 1 to 10. We need to find the first term and we need to find the 10th term. So t of 1 is going to be 13 times 1 minus 5. So our first term will be 8. And then t of 10 is going to be 13 times 10 minus 5. So it's going to be 125. So our sum here, 10 divided by 2 times 8 plus 125. Half of 10 is 5. 8 plus 125 is 133. And 5 times 133 is 665. And I know on the paper I said we are doing 53A, I think I posted, but I want to do D. I want you guys to try it. So same thing, t equals 1 to 30 of negative 5t plus 10. So try this one. When you are done, type it in the chat. I'll let you know if you got it right, and then you are free to go if you finish it quickly. I'm not going to say anything else other than I'll see you guys tomorrow and test next week. Your grades in Power School, I'll finish typing them in today, I think. Try this one on your own. When you are done, type it in the chat. And